Hi, my name is Xavier with BioTek. In this introduction video, I will show you what BioSpa is and how it works. I will also demonstrate, after that, some of the typical assay workflows that you can automate with this system, such as multi-day cellular assays, cell staining and fixation protocols, as well as more cumbersome biochemical assays such as ELISAs. But first, let me show you what BioSpa is and how it works. BioSpa 8 is an automated incubator that fits in a biosafety cabinet. Its main components are an incubation chamber that you can see right here, 4 drawers on which you can load your samples, and a robotic arm that automates the sample handling process. You can see a plate washer and dispenser on the left of the system, and a plate reader and imager on the right of the system. BioSpa 8 is compatible with many of BioTek's instruments, allowing you to customize the system to your needs. Here, for example, with liquid handling only, or here with a washer dispenser and a simple absorbance plate reader. We will see later in this video how BioSpa 8 integrates with these devices. The incubation chamber here is equipped with temperature control. 21 sensors are used to guarantee homogeneous temperature control for best data quality. The system is also equipped with CO2 and oxygen sensors. You can connect the BioSpa 8 to gas tanks, and gas levels will be controlled automatically. Finally, a water pan is used for humidity control. This system is equipped with a level sensing alert. All of these parameters can be controlled and monitored for up to 2 weeks to automate long cell-based assays as well as long biochemical assays. As you can see on this picture, BioSpa 8 is compatible with low-density cell culture microplates, high-density assay microplates, as well as cell culture vessels such as T25 flasks and cell culture vessels. The robotic arm is equipped with a gripper that can handle lidded and unlidded microplates and will automatically remove lids when required. For optimal cell assay conditions, the system is equipped with a user-replaceable HEPA filter, and the incubation chamber is easily accessed and cleaned through this top access door. BioSpa 8 interfaces with other devices through BioTek's existing software packages. Gen 5 for readers and imagers, and LHC for washers and dispensers. All you do with the BioSpa software is call existing protocols to create your workflow. What you see here on the right is a BioSpa workflow. Each of the 3 liquid handling steps I am highlighting calls a different pre-programmed protocol. And the final imaging step here just calls the same protocol multiple times to perform a time-lapse measurement. We will review this 4-day workflow in more detail in the next video. To run the system, simply load your plates and hit start. The software generates a schedule that shows you all of the assay steps for each plate, as well as the expected duration of the entire run. During the run, all assay parameters are recorded continuously. You can see here a run log, as well as a parameter chart. If any parameter goes out of range during the run, you will get notified immediately by text or email. With BioSpa 8, you can finally take control of your workflows. Here, I will demonstrate how you can use BioSpa 8 to automate a 4-day live cell workflow in microplates. The system you see here uses a multi-flow effects on the left for all the wash and dispense steps, and a citation on the right for imaging. This entire system has been designed to fit in a biosafety cabinet to keep your assay sterile for better data quality. Here is the workflow for this 4-day cytotoxicity assay. Day 1 starts with the cell seeding step. After seeding, the cells are incubated at 37 degrees and 5% CO2 for 24 hours. At the end of day 1 incubation, the cells are washed with fresh media. A serial dilution of the test compounds is dispensed into the wells. Hoechst and Promegaz CellTox green stains are added as well for imaging. Once prepared, all microplates are imaged every 2 hours for 3 days. Automating this type of workflow removes many sources of error, which will increase your data quality. Now let's see how to program this workflow in the BioSpa software. First, on the left, select the number of microplates to be processed. Second, set the environment parameters, in this case, 37 degrees and 5% CO2. Finally, on the right, program the steps to be automated by BioSpa 8. As you can see, the software was designed to make sequences like this one simple to program with just a few steps. First, the cell seeding step. As described in the introduction video, this step simply calls an existing liquid handling protocol, as seen here. The next step is a one-day incubation, during which the microplates will be stored in BioSpa 8. Next, plate 1 and plate 2 are treated separately using two different serial dilutions. Fluorescent stain addition is performed at the same time. Once the plates are ready, they are imaged every 2 hours for 3 days. The imager software, Gen 5, will automatically analyze the images and provide a live dead cell count over time. Now let's get the system ready. I have my two lidded sterile microplates right here. My cell suspension is connected to the multi-flow FX, and the system has been programmed to notify me tomorrow when I need to connect fresh reagents. The software will generate a timeline that will show me every single step for each one of the plates and will also estimate the end of the run. I am now going to load the two microplates in the system. And hit start. You see here the gripper retrieving a lidded plate from the incubation chamber. BioSpa automatically removes the lid for cell seeding. The cells are dispensed by the multi-flow FX dispenser. The plate is re-lidded and transferred back to the BioSpa 8 for a one-day incubation. All these steps can be performed inside a biosafety cabinet to prevent contamination. Prior to the next step, the following day, I receive a text notification that instructs me to set up fresh reagents on the multi-flow FX. Plates are retrieved by the robot. They first go through a gentle wash step using fresh growth media. Then, compound dilutions and fluorescent stains are added. Once all reagents have been added, the microplates are imaged kinetically over 3 days. You see here a plate being transferred with its lid to the citation imager. Between two imaging cycles, the plates are incubated inside BioSpa 8. You can see on the right a full event log with timestamps, as well as a parameter chart here. You know exactly what happened and when, which removes a lot of uncertainty when it comes to a long assay workflow like this one. A link to the final assay data is embedded in the session file, so you can directly access it. During the session run, images have been automatically processed and analyzed, and the final time-lapse and live dead cell count is ready for you to review. With BioSpa 8, you can finally take control of your workflows. Here, I will demonstrate how to run a 30-hour cell assay workflow, including cell fixation and staining steps. The system you can see here has a multi-flow FX on the left for all of the washing and dispensing steps, and on the right, a citation imager. This entire system has been designed to fit inside a biosafety cabinet for improved sterility during the entire run. Here is the workflow for this 30-hour gene expression assay. GFP expressing cells have just been treated with different drugs. The BioSpa workflow starts with a one-day incubation at 37 degrees and 5% CO2. At the end of day 1 incubation, the cells are washed and fixed with paraformaldehyde for 15 minutes. Excess fixation reagent is removed with a wash step, then both Hoechst and Texas red fluorine stains are added and incubated for 15 minutes. A final wash step removes the excess stain and adds 100 microliter of PBS. Once prepared, all microplates are imaged with blue, green, and red filter sets. Automating this type of workflows removes many sources of error, which will increase your data quality. Now, let's see how to program this workflow in the software. First, on the left, select the number of microplates to be processed. Second, set the environment parameters for the 24-hour incubation, in this case, 37 degrees and 5% CO2. Finally, on the right, program the steps to be automated by BioSpa 8. As you can see, the software was designed to make sequences like this one simple to program with just a few steps. First, the one-day incubation step, during which the microplates will be stored in BioSpa 8. This is followed by the first wash step that also includes the addition of paraformaldehyde for fixation. As described in the introduction video, this step simply calls an existing liquid handling protocol as seen here. A 15-minute incubation is added for the fixation step. Then, the samples are washed again and fluorescent stains are added. Another 15-minute incubation is used for the stains. Then, a final wash step removes the excess of stains and the plates are ready for imaging. The imager software, Gen 5, will automatically analyze the images and provide quantitative gene expression information. Now let's get the system ready. I have my 4 lidded microplates here. The wash buffer, paraformaldehyde, and stains are all connected to the multi-flow effects. The software will generate a timeline that will show you all the steps for each of the microplates. It will also give me an estimated time for the end of the run. I am now going to load the 4 microplates in the system. And I'm going to start the session. For the first day, the microplates will just stay inside the BioSpa 8 under controlled environment. At the end of the incubation period, the samples are ready for fixation. You see here the BioSpa 8 gripper retrieving a lidded plate from the incubation chamber. BioSpa automatically removes the lid prior to washing and dispensing. The multi-flow effects washes the cells, then adds the fixation reagents. The plate is transferred back to the BioSpa 8 for a 15-minute incubation. Plates are then retrieved by the robot for washing and addition of the fluorescent stains. Another 15-minute incubation occurs. Finally, plates are washed and PBS is added. The samples are ready for automated imaging and are transferred to the citation imager. Here is the BioSpa session at the end of the run. You can see on the right a full event log with timestamps, as well as a parameter chart here. You know exactly what happened and when, which removes a lot of uncertainty when it comes to a long assay workflow like this one. A link to the final assay data is embedded in the session file, so you can directly access it. During the session run, images have automatically been processed and analyzed, and the final GFP expression level calculations are ready for you to review. With BioSpa 8, you can finally take control of your workflows. Here, I will demonstrate how you can use BioSpa 8 to automate an ELISA workflow. On this system, on the left, you see a multi-flow effects that will automate all of the wash and dispense steps, and on the right, an EPIC to plate reader for the measurement step. Here's the workflow for this ELISA assay, which includes multiple washing and dispensing steps and a final read step. In this workflow, samples are pre-dispensed in the microplate and ready for a first 60-minute incubation at ambient temperature. At the end of this incubation, plates are washed and 100 microliters of the conjugate reagent is added. A 30-minute ambient temperature incubation follows. Plates are then washed again to remove the excess of conjugate, and 100 microliters of substrate is added. A 30-minute incubation allows for color development. At the end of the incubation, 100 microliters of stop solution is added. At this stage, the plates are ready to be transferred to a plate reader for measurement at 450 nanometers. Automating this type of workflow removes many sources of error, which will increase your data quality. Now, let's see how to program this in the software. First, on the left, select the number of microplates to be processed. Second, set the environment parameters. This doesn't apply here, since all incubations are done at ambient temperature. Finally, on the right, program the steps to be automated by BioSpa 8. As you can see, the software was designed to make sequences like this one simple to program, with just a few steps. Each of the sequence steps corresponds to one of the ELISA workflow steps. The first 60-minute incubation at room temperature, then a wash step, followed by the conjugate dispense step, These two steps are combined since the multi-flow effects dispenser can handle both. As described in the introduction video, this liquid handling step simply calls an existing protocol as seen here. After dispensing the conjugate, there is a 30-minute incubation step, followed by a wash step and the addition of 100 microliter of substrate. Another 30-minute incubation allows for color development. The reaction is then stopped with 100 microliter of stop solution. A final read step, calling an existing plate reading protocol, automatically prompts BioSpa 8 to transfer the plate to the EPIC 2 plate reader for measurement at 450 nanometers and automatic data analysis. Now let's get the system ready. I have my 5 assay microplates here. The wash buffer, conjugate, substrate, and stop solution are all connected to the multi-flow FX. The software will generate a timeline that will give me the steps for each of the microplates, and it will also give me an estimated time for completion. I'm now going to load the microplates on the system and start my session. Here, you can see BioSpa retrieving the first sample plate and delivering it to the multi-flow FX for washing, then conjugate dispensing. After this, the plate is returned to BioSpa for a 30-minute conjugate incubation. The plates are then retrieved after 30 minutes, washed, and substrate is dispensed. As for the previous steps, this is handled as one step by the multi-flow FX since the device can perform both wash and dispense steps. After substrate has been added, the plates are stored back in the incubation chamber for 30 minutes. For the final liquid handling step, 100 microliter of stop solution is added, after which the samples are ready for measurement at 450 nanometers. The read step in the session automatically prompts BioSpa 8 to deliver the plate to the EPIC 2 plate reader. Here is the BioSpa session at the end of the run. You can see on the right a full event log with timestamps, as well as a parameter chart here. You know exactly what happened and when, which removes a lot of uncertainty when it comes to a long assay workflow like this one. A link to the final assay data is embedded in the session file, so you can directly access it. During the session run, Gen 5 automatically plotted standard curves and calculated unknown sample concentrations. In summary, there are many benefits of BioSpa 8 for biochemical assays. The system fits in a safety cabinet to limit contamination risks. Automation of complex workflows like this one is a step towards better data quality. The interface is designed to make programming of complex sequences fast and easy. Automated notifications allow you to remain in control throughout the process. And a full record at the end of the run means that you can better trust your assay data. Finally, BioSpa 8 is also designed to automate life-cycle workflows, which greatly expands its utility well beyond the automation of biochemical assays. With BioSpa 8, you can finally take control of your assay workflows.